What's up, guys? I know it's been a while since I've had an update, but things have been crazy. Been doing the whole back to school thing, plus getting other things ready for some other upcoming events that are going on. Plus there's been a lot of birthdays and whatnot in my family, so it's been a while since I've had a chance to make a movie. And also I've been working on a couple of different things for you guys, as well as for myself. Actually, it helps me out too with what I was making, but I figured I'd share with you guys. But there are a couple of projects that are taking quite a significant bit of time. I can't just kind of bang them out in an evening like I'm able to do some of my instructional videos. Those of you that don't know, most of my videos that I make, the instructional videos and stuff that I do, usually I do them in a night. It usually takes me maybe 3 or 4 hours to do it. So usually what I do is it has to be things that are fairly simple that I can, if it's something I've never done before, I have to basically figure it out, within just a few hours and get it all working and connected and whatever else in a few hours, and then shoot the video and everything. And then over the next, day or so, couple hours a night each day, I have to then edit the video and put it all together for you guys to see it. So it takes a little bit of time, and anything that's fairly involved, it takes maybe some fabrication or whatnot, really takes quite a while to get out. It'll take me, kind of weeks, to get it out. So anyway, just so you know, why it's taking me a little bit of an insight of why it takes me so long to get videos out sometimes. Just, life happens. I don't do this for a living, so, things happen. But anyway, good news is, I got, some more little goodies that we'll be working with. But one thing that I will show you guys, I did finally complete it. And like I say, with all my videos, I like to go ahead and put the whole thing together, software, hardware, everything, and make sure that it all works and functionally is solid, before I go showing it to you guys and whatnot, because I don't want to, I don't want to be showing off something that I've never tested before, or give you guys code that has never been put on the device that I say it works for. I'm not going to do that. So I'm going to make sure that everything works, it's proven, tested, and everything. That way, when you guys do have questions and problems with it, or if you guys are redoing it for whatever purpose and you run into a snag or something, I'll be able to help you guys out. You guys can ask about it, and I know because I actually have applied it to the hardware and tested it. A lot of guys don't do that. A lot of guys will just kind of throw out something that they feel is probably the way that it works, and a lot of times it doesn't work. I've ran into that 3 times, and anyway, so I like to test my stuff out and make sure that it works before distributing it to you guys. That way I know that in my lab it definitely works. That way I can work with you guys to maybe recreate the same thing on you guys' benchtops. So anyway, without further ado, I'll show this to you. Like I said, I'll probably do a separate video that will actually show at least the kind of overview of this, since it was kind of a pretty custom deal. I'm not going to show you the whole soldering of everything, but I mean, by now, if you guys have checked out my channel, or if you want to just check out, my channel, you guys know how to solder and like scribe boards and do all that stuff. I've shown all that on my channel. So if you don't know that, check those videos out. Just hit my channel button, hit subscribe while you're there. That way you can check up on other interesting videos. But, just check those out on my channel. Anyway, for those of you that don't know, I also, another one of my hobbies besides electronics, I have two kind of main hobbies. Electronics is number one, obviously, but the next hobby that I do is I do a lot of home brewing. It's a lot of fun. It's very social, and it's very interesting, especially if you get into the science of it. It's very scientific and very interesting, which for a bug like me, with learning and scientific stuff, it's fantastic. And the great thing about it is you can combine electronics with it too. So that's basically what this kind of funky looking little deal is a lot of home brewers do what's called kegging. They actually keg it, and they put it into usually chest freezers. Well, the only problem with a chest freezer is it's a freezer. So freezers freeze things solid, correct? Well, the problem is if you put a liquid in there, and this can work for not even home brewing, this can work for like if you want to make your own pop. I know they have those cool little machines now. You stick the pop bottle in that carbonates it, and it takes, I think, a CO2 charge or whatever, and you put the syrup in it and whatever. But, I mean, if you're doing like a big batch, you're wanting to take and mix the syrup into like a 5-gallon thing of water on the stove, and boil it so that it, sterilizes it and all that, and then put it into one of these little pop kegs and then carbonate it with some CO2. you'll need a place to put it. And usually those keg canisters are pretty good size. And so you chest freezer or something that's got some fairly good size to it to put it into that's refrigerated. Well, like I said, the problem with the freezer is some freezers, I've seen ones like the one I have has it already, but some of them have a refrigerate setting on them and you can actually set them, but usually it's a very tiny window. You don't have a whole lot of range with that since it's really a freezer and not a refrigerator. Well, that's where something like this comes in handy. I've looked at other controllers and they're pretty expensive. But what I've done is I basically made a temperature controller for a chest freezer or any type of freezer that you want to control the temperature of. What this little thing has is it's got a thermal probe. That's what this little thing is hanging off of it. You'll stick this inside the freezer, and it's small enough that you're not going to lose any, any air or anything when you close down onto it. It's not like you got this big honker thing going in there where you might, lose some refrigeration. It's real small. And then I just put it into a off-the-shelf little box. And what it does is it controls a receptacle. It's got a little LCD screen. See that there? And I want to do a shout out for DC Electrical, Chris out over there. He donated a bunch of parts. I don't know if you guys saw that mailbag video, but there was a mailbag where I took apart piece of mail that I got and had a whole bunch of screens and components and a bunch of different things in it. And Chris donated, and this was one of the displays that he had. He gave me 2 of these, so I don't know, we may make something else kind of cool out of these little guys. But he made this so very cool little I can't remember if was it 8 by 2, I think, dot matrix LCD. I think it's something like that. It might be more. Forgive me, I don't remember it right off the top of my head, but it's a little LCD screen. I think ultimately what I will do, I was trying to whip this out pretty quick, so it basically has a fixed setting in it. It's fixed to about, I think it's 3 or 4 degrees Celsius is what it will regulate to right now. It uses a microcontroller, but what I think I'm ultimately going to do is, well, I don't have one out right now, but I'll put here, I can do it with a knob. I'm going to put a kind of like a selector. Since I've got spare ports on the PIC micro that I have in here, I think what I'll do is I'll put another, I've got some potentiometers laying around here, so what I think I'll do is I'll put another analog input on and put a little knob on here, kind of like this, and you can adjust the temperature, and then that way you can adjust what kind of temperature you want. So if you want it to be 5 degrees or 7 degrees, or change it around, make it where it's Fahrenheit, and then you can do, all those numbers with Fahrenheit. But basically how this is going to work is it has a cord on it, and you plug the unit in to the wall, like this, like that, and then the freezer, let's pretend this is the freezers, you plug the freezer into this, like so. And then what that'll do is it'll basically it'll cycle the freezer on and off, and you just turn the freezer all the way up, and it will basically cycle the freezer on and off and regulate the temperature inside the freezer to what you have set on your LCD screen. It also gives you, it has the readout of the temperature that it's at currently, as well as your set temperature will read out on the LCD screen. And so look for the video for this thing, because I'll be showing you what all's inside this guy and how he works and how to build one yourself if you want to, as well as I'll post the code for the little chip guy that's in there and everything. So kind of cool. So that's another project that I'm working on. Another one is this thing. You should be seeing the video. I filmed at least some of the fabrication for this guy. I haven't filmed the rest of it yet, so I haven't had time to. I had to finish up that controller actually. But anyway, what I'm doing here is building another deal for homebrewing. Homebrewing is really fun. You can have what's called a stir table. What those are, and like I said, it doesn't have to be for homebrewing. It could be for those of you that do a lot of chemistry at home or things like that. This works great for chemistry type deals. What you do is normally you'll have these stir tables. What they are is they basically have, let's pretend that this is fully assembled, they have a magnet on a motor that spins. And then what you have is you have what's called a stir bar, which it looks like a little pill. See that? And you put that inside of a glass usually. I don't think I have anything. Yeah, I do. Here, hang on just a second. Go over here and get something. What would look the best? Yeah, that'll work. I have this stuff out for another thing, which I'll show you here in a minute that we'll be looking at too. Regular Erlenmeyer flask. This one is a 200 milliliter Erlenmeyer flask, and I just dropped the stir bar. Doggone it. All right. Good grief. All right. Anyway, you put whatever it is here, put whatever liquid you want in here, in there, and then you put the stir bar in the bottom. Okay. So the stir bar goes in here. Well, now normally, like I said, there'll be a magnet on the inside of this, and that will snap that stir bar to it. And then what it does is it spins that stir bar really, really, really fast, and it creates kind of like a vortex. You know how when you, I don't know if you've ever seen those when you're a kid, the little tornado tubes or whatever, you know, you can spin them and it creates like a little tornado. Essentially what it'll do. And then when you add any type of powders or any type of, you know, powdered whatever, you know, in the case of like home brewing stuff, you'd add sugars, yeast, maybe some malt extract of some sort or something like that, and it'll basically stir it all up for you, so you don't have to sit there and stir and stir and stir and stir and stir, you know, and it gets the clumps out and everything. If you put something in there that has a tendency to clump, like I know dry malt extract will try to clump and stuff, it'll knock all them clumps out because it gets sucked down to that stir bar, and that stir bar breaks it all up. So it's a very useful tool. And I was looking at them, they're really expensive for some of these stir tables. And I'm like, you know, all they are is a motor with a magnet on it spinning. And then you buy these little stir bars, you get them off Amazon for, I don't know, $3 or $4, you know, and they come in all different shapes and sizes. So you might as well just build one yourself, you know. So it's another thing that we'll be doing. I'll show you guys how to build that. And it'll also have another knob on it where you can regulate the speed of it using like an LM317 or something, some adjustable voltage regulator that's you know, capable of producing enough current to spin a little motor, kind of like this one. In fact, this is the little motor that's going to be in it, but just a little DC motor, and spin that around. So that's nothing real complicated, but it takes time because I have to fabricate some stuff. Like inside that box, I have to build a little bracket thing that'll hold the motor and all that stuff. So you know, it takes some time. Another cool one, which is kind of neat, is especially in home brewing, you have pH to deal with. And I saw this. I'll have to give a little bit of a shout out to someone. They didn't contact me or anything. I just saw them. I don't know if any of you follow Hackaday or have ever seen Hackaday, but I recommend you go check that site out. The site's pretty cool. They got some pretty cool stuff on there, and they show a lot of different hacks, hackers, lots of people like me, different people from the YouTube educators and things like that, all appear there and whatnot, and they do a really good job of reporting on different cool stuff, widgets and things that are coming out. In fact, they got a really good 3D printing section that talks about 3D printers and all that stuff. But there is a guy whose website is Sparky's Widgets, I think. Hopefully I'm saying that right. If not, I'll put a link. I'll put a link down below so that way you know where I'm talking about. I think it's Sparky's Widgets or Sparky's Gadgets or something like that. But anyway, I saw him. He was on Hackaday on, they were at the Maker Faire, and this guy was there, and he made something that interfaces with these, which I may end up picking up one of these just to see what it's like, but I figured we'll make one ourselves. But anyway, pH probes. Now, I know a lot of you may be wondering what that is, but pH is something that, you know, is like water pH. It tests the, whether it's acidic or more caustic or more base-like or neutral, you know. So I guess that's, you know, that's basically where you're at. And so basically like a sanitizer that you'd use, is more acidic because it kills bacteria and whatnot. Well, you got to make sure that it doesn't lose its acidity and things like that, as well as when you're doing mashing, what's called all grain, if you ever do all grain brewing and stuff like that, pH is very, very key, especially even with, let's say a fish tank. You know, if you have certain types of fish, especially tropical fish and things like that, pH is very, very key. You want to keep some litmus paper around or whatever. Well, the cool thing about a pH probe, this little guy, is that it's an electronic device. See, it's got a little BNC connector on the end of it. You can pick these up on eBay for really, really reasonable prices. I think this one was only like $4 or $5, you know. Now they do ship, at least if you're here in the States like me, they do ship from overseas, so it takes a little while to get it, but, you know, hey, if you're going to buy one of these, normally these things can be hundreds of dollars, you know, and this little guy, I think it's fairly accurate. I haven't had a whole lot of time to play with it, but what time I've spent playing with it, yeah, it's not bad for $4 or $5. I mean, you can't go wrong with this little guy. So anyway, that's going to be something we're going to build basically the amplifier interface for this, because you want to amp the signal, because it's in it's in millivolts. It's very tiny, so you want to amp up the signal as well as do some noise rejection and things like that. So we may play with all that, and so that's something to look forward to. As well as I also picked up, just because I could, some of these little guys. Now, those of you that know what these are, you don't have to listen to me, but if you know what these are. But what this is what's called a Peltier junction. These things are actually really cool. They're basically a heat pump. They're a solid state heat pump is what they are. And they're electrically driven. Now, I don't believe there's any gases or anything inside. But I could be wrong. I haven't looked up how these are made in a very long time. I first ran into these back when I was in college, which was a long time ago. So I don't remember the total research on these, but I do know that the one cool thing about them is they are very, very, very efficient at transferring heat from one plate to the other plate. And how that works is if you hook current up, let's say you hook the polarity up where, red is positive and black is negative as usual, this side will get arctically cold, whereas this side will get like super, super hot. And what it's doing actually is it's actually taking the heat that is seen on this side and it shoves it to the other plate. So, like I have it here, let's see, I take my deal off because I was playing with it. If you mount it to, let's say, some sort of a heat sink, now I was taping stuff to it, I really don't need this tape on there. But basically, if you mount it to a heat sink with some thermal grease, which is what I did. Okay, that's just one of my heat sinks. I had this was a chipset heat sink was what this actually was. It was out of one of my computers. Motherboard that died. I took the heat sinks out of it because I figured I'd use it. And there you go. And it has a little fan on it, too. That's what this piece is here. And this thing will get, and I mean, we're talking fast. That's what's so cool about this. This guy can go from room temperature to freezing water. Like I can actually put droplets of water in here and freeze it to it in literally like maybe 30 seconds. I mean, they're maybe even faster than that, maybe like 15 to 20 seconds. This will get that cold. It'll freeze water in like 15 to 20 seconds. These things are amazingly efficient. However, you have to have a big cooler like this. In fact, I'm going to play with it with one of my bigger coolers. I've got a bigger heatsink cooler for processors. And actually, if memory serves right, I think that's what these were invented for. The reason these were designed was for processors. You sandwich one of these bad boys between the processor and the heatsink. And what it will do is if you have rapid spikes in temperature, let's say you have something that, let's say it's not a processor, let's say a MOSFET. Say you have a MOSFET and you've got some huge load that could happen. I don't know. Maybe it's I don't know. Maybe it's in some sort of a battery. Let's say you're doing lithium batteries, and you have maybe a MOSFET that's controlling that battery, switching it on and off. And when you turn it on, let's say you've got some huge current load out there. You're starting an engine or something, and so you slam the MOSFET on. Well, the MOSFET's going to get hot, just bang. It's going to get hot really quick. Because of that, well, that super spike in temperature, depending on your temperature coefficients of your heatsink sitting on top of it, you may not be able to get the heat out of the package fast enough to actually cool it properly, and it could actually burn up because of that heat spike. Okay, so what you do is you can throw one of these guys on there, and when you see that huge heat spike, it just yanks it out of there and throws it into the thermal mass that you have bolted to it very, very quickly. So it basically improves your temperature constant, or your temperature coefficient, I guess you'd say, that transition, piece. It'll improve that. So those things are kind of cool. Another really awesome thing about these little guys, another really cool thing, is they can generate electricity too. This is really awesome. You can take, and I've seen this done before, and we may try this actually ourselves, but if you take the side that gets hot, which is this side, depending on the polarity, because I believe you can swap the polarities on this, and it swaps the sides. The other side will start getting cold, and the other side will get hot. So based on which way the current's flowing is which way it'll either produce heat or, it shifts heat from one side or the other based on which way you hook it up. But if you put heat on one side. Let's say, like, I know for a fact the side with the writing, if you hook it up plus here and minus there, this side gets cold, side with no writing gets hot. If I were to take this and stick it to the bottom of, let's say, I don't know, like a fire pit, if I were to stick this to the bottom of a fire pit and build a fire on top of it, it would generate electricity. And how much electricity do you have to ask? Because I know solar panels can be misleading. You need a lot of solar panels to do something like charge a battery or something. These guys, if you stick a fire on top of this guy, which fires, you know, shoot, they get up to, you know, especially when they burn down to coals, you know, 1500 degrees or so. You get that much temperature on these guys. They will produce enough current and voltage. I mean, the voltage is kind of all over the place, so you'd have to regulate it, but it will produce enough current to charge a cell phone. So that's another cool thing, and we may do that, you know. So I don't know. These were on sale, and I just picked up a couple of them because they're cool. What else? Oh, one more thing to show you. This is what I mean. I've got a lot of stuff going. It's just, we're getting more into more complicated stuff like that. This guy, this little pH probe, you know, that's going to take some tests and some debug to get this guy working. That's why I may just get, like I said, for the quick and dirty, just to show you how one of these works and whatnot, I may get the little header from, Sparky's Gadgets, Sparky's Widgets, whatever that is. Like I said, I'll put a link down there so I'm saying it right. You know, sorry about that. If you see this video, you know, I can't remember exactly what your website's name is, but anyway, I will correct it and put it down below so people will know. But you know, I mean, get one of those just to show you guys how one of these works, because these are pretty cool. And then we'll end up designing one ourselves or whatever. So anyway, the last thing I want to show you is I bought. Remember, I did do a video previously for icstation.com, and they have a lot of cool deals. They have great prices on really cool stuff, and one of those was very affordable. RF. I know I told you guys I was going to do some RF videos. I've got an RF transmitter and an RF receiver, and so we'll do some fun with, you know, sticking this little guy on a battery powered something and sticking this guy somewhere else, and we'll see if we can't, you know, do some communication between the two of them. So that ought to be pretty cool. I was going to build these. I've worked out drawings and whatnot, how to build these and everything, but you kind of gotta wind the little inductors yourself, and you know, you gotta get, I don't have any of the transformer wire on hand right now. I'd have to order a spool, and you know, because you need that wire that has the insulation that's can't think of the name of it, but that spray-on type insulation that you have to scrape off, you know, and all that fun stuff. You have to get that and whatnot, because I mean, you could use a normal wire. It's just with the insulation on it and everything, it gets so thick and big and bulky, and it's just a mess. So I saw these. This was super affordable. It actually comes as a kit, so I just picked one up. You know, why not? You know, why mess around with it? Sometimes, if you want to do it, I recommend, if you want to do things from scratch for the learning experience, I say that's fantastic. You should just do it. Go for it. But I mean, at the same time, if you can, you know, why reinvent the wheel? If you're needing something for a project and you need to just slam it in there, by all means, if it's already made, go get it, you know. And so there's, if you want to be a purist or whatever you would call it and build everything from scratch, do it. If that makes you happy and you have the time, go for it. I tell you, it's a wealth of knowledge doing things from scratch and whatnot. But if you're in a pinch or whatever, and you need to just get something that will work, yeah, you can pick some of this stuff up. And IC Station, that's a great place. And no, I'm not endorsed by them. They didn't pay me or anything like that. They just have a good website and they offer good products at a reasonable price. And so I recommend it to you guys. I'll show you guys that and let you guys know that, hey, you can pick this cool stuff up there for a good price. Looking around, the reason I keep turning around is I keep making sure that I'm not forgetting anything. Oh yeah, well actually I am forgetting something. I'm still forgetting about the, oh, it's in that box. I'm still forgetting about it. I need to do the DACs, digital analog converters. We need to do that, which I was thinking of building maybe a programmable load out of that. I've seen some different ways of doing it. I got to get some specific MOSFETs, because to build a programmable load, those of you that don't know, basically where you can like type in, I want to pull 5 amps out of something, you know, and you hook up some sort of a power source and you want to draw 5 amps out of it, whatever your circuit may be, and you push the 5 amps and then it draws 5 amps out of it. And then you put like 10 amps and it draws 10, or you put 500 milliamps and it pulls 500 milliamps out. To build something like that, what you need is you need specific MOSFETs that can do that. What I mean by that is you have to have MOSFETs that can run in the linear region, basically not fully on and not fully off, basically where normally, remember, if you watch my transistor video on MOSFETs, our MOSFETs have that RDS on. They basically have the channel between the drain and the source on, let's say, an N channel. On the drain and the source, there's actually a resistance there. Well, you can actually vary that resistance by running the transistor in the linear region. However, not all transistors are created equal. They're not all the same. So you have to get a specific type, and I'll go over that when I actually do the video, but you have to get a specific type that can be ran in that linear region, because a lot of the other main, like, switch mode type transistors, they're only made to be either on or off. They're either full saturation or in the cutoff. They aren't made to run in that linear region that's in between. And so they will actually hotspot, is what it's called, and burn up internally. Even though you get like a great big huge one, a lot of times they will burn up inside if you run them in the linear region. I don't care if they're a 20 amp rated, you're only putting 5 amps through it. If you choke it down to 1 amp, you're probably going to end up seeing hotspotting and burn up the transistor. But we'll go over that in that video. So anyway, alright guys, I probably rambled on long enough for you all, but that's some stuff that's up and coming. Sorry it's taken so long, but you know, like I said, some of these are kind of involved, especially that little controller guy that I showed you. This little stir table thing is fairly involved because it requires fabrication. I have to go out to my garage and machine out parts and things like that, and so it takes a while to actually do that. Plus I have to pick up the materials and whatnot, and so it is a little bit of a chore to get some of this stuff done. We're getting to a point where I've kind of thought of all the simple stuff I can think of. That's where you come in, ladies and gentlemen. If you guys have any ideas for videos at all, I am totally all ears. I will listen to whatever you get. I have a couple, 3 different viewers that they give me new ideas all the time, and they're fantastic. And I've put them, you know, added them to the list. And so I will do the same for yours. So if you guys have any idea, especially if it's a simple idea, if there's some little thing that's like, hey man, it'd be really nice if I could get a quick explanation on this, or I could get a quick demo of this, or something like that, or if there's certain parts that you guys want to use, maybe want to learn more about or whatever, suggest them. I'd love to get into maybe some part that everybody's using that I don't know about yet, and I'll get in, research it, find out some cool stuff about it, and I'll make a video about it and share with you guys the different discoveries and lessons that I've learned working with those parts as well. So definitely leave likes, comments, all that fun stuff. Comments is the best way. I try to do the whole forum thing. I don't know if that's really working out. That forum may go away. I haven't really had a lot of response on that. And to tell you the truth, I really haven't had a lot of time to mess with a forum and keep that going. It's kind of a full-time job just keeping YouTube up and going. So we may, I'll leave it up for a little longer, but I don't know. I think if I see an increase, then yeah, maybe we'll use it. But you know, I don't know. I think really the best way probably still is to just leave comments. You know, just leave me a comment, and we ought to be good. So guys, with that, I think I'm done. Hope you're having a good week. Getting ready to have a good week. I guess it is the beginning of the week now, isn't it? Today's Sunday. So, hope you guys had a good last week. Hope you had a good weekend. Hope you guys are making all kinds of fun stuff. And look forward to new videos that'll be coming out. We've got quite a few, like I showed you, we got quite a few things in the pipeline. So, ought to be some cool stuff coming out. Like, subscribe, share, all that fun stuff. Check me out on Twitter. And Instructables, if you haven't checked me out in those places, especially Twitter. Lots of times when I have late videos, I'll try, I don't always, but I'll try to give some sort of a text update on Twitter. So if you guys aren't part of Twitter, go ahead and see if you can't find me there. I'm misperry at the Twitter. So if you go to twitter.com/misperryee, you'll find me there. You can follow me, and then that way you'll get updates on when videos are coming out and things like that. So, as well as I like to retweet a lot of stuff. I follow a lot of different electronics communities, and I like to retweet a lot of the cool stuff that I find. So, that's another treat that you'll see. You get to see some latest technology things and whatnot on my Twitter feed. So, anyway, with that, guys, I think that ought to do it. So take care, keep coding, keep building, because that's what it's all about. Take care, guys. We'll see you next time.